So we set up the IDE, which is important. Now let's also set up a starting project, which we'll use throughout this course in the different course modules. So basically a project setup with which we can start every course module to then write our code there. Now, as you will see throughout this course, writing code doesn't require a complex setup in general, but here I want a project where we can write code, compile it, and then immediately see the output of that code in the browser. And for that, I'll first of all add a new index.html file, and you can add this in any empty folder. The two other files or folders you see here are just config files for Git in case you're using version control, and for my editor, which sets the zoom level. So that's all I have here. But in that index.html file, I will now initialize it with a base skeleton. And for that in Visual Studio Code, you can just type HTML, choose that HTML5 option. If you're not getting this menu, just press Control and space, choose the HTML5 option and hit enter, and you'll get this skeleton. There we could enter understanding TypeScript here as a title, but that does not matter too much. More important is that here you add a script tag in your head section and add a source and point at app.js here and add the defer attribute. This tries to import an app.js file, which of course right now doesn't exist, and it will then of course also execute it if it finds it. This allows us to view our changes, our code changes, directly on the screen in the browser, or if we're just logging something to the console, in the browser DevTools. Next, I will add an app.ts file. That's the file, a TypeScript file, where we will write some code. And there, for example, you could console log your code goes here, or whatever you want. You can console log whatever you want here. And if you do that, you can compile this file with TypeScript, which we installed earlier. For that, you can open the terminal integrated into the editor here and simply write tsc app.ts. This compiles this TypeScript file and generates an app.js file now, which is the file we're importing here. And if you now open this index.html file, you see whatever happens in here. You kick off the logic you wrote in here. And either that's logic that manipulates something on the DOM, or like in this case, it's logic which simply gets logged to the console. So here in this case, I opened this HTML file in the browser. You can simply double click on it outside of the IDE, so in the normal Windows Explorer or the Mac Finder. And then maybe open your developer tools if you're just logging something to the console, and you'll see your log here. Now that's nice, but whenever we change something here in our code, we have to manually recompile. Well, that is what it is for now. It will change later in the course, but we also have to manually reload this page here. And to speed this up and make sure that you don't have to do this whenever you change something, we'll actually also add another tool here to this dummy setup, which we'll use throughout this course, so that this happens automatically. Now to install such a tool, let's run npm init here in this project folder. The npm command is available if you installed Node.js. Make sure that for that you visit nodejs.org and download and install the latest version you find here. For the moment, we're not going to write any Node.js code, but Node.js comes together with the npm tool, which we can use to install third-party dependencies or useful tools that speed up our development, and for that reason, we need it here. So with that installed, you can run npm init in this project folder. Simply hit enter, and you can answer all these questions here with the defaults by simply hitting enter all the time. And once this completes, it gives you a package.json file, which looks something like this. And now you can run npm install to install a dependency which is exclusive to this project. So to install a tool, you could say, which you can use in this project. --save-dev to mark it as a development only dependency, so a tool that helps us during development and does not contain any code which will execute as part of our main code. And the tool name is light-server. If you hit enter here, this installs this extra tool. And once this finishes, just go into your package.json file and in the scripts part, add a comma and add a new script which you name start. And then, as a value between double quotes, enter light-server. So that name of the package which was added here. If you now hit enter, You can run npm start here to start this start script, and light server is a simple development server which always serves the index.html file next to the package.json file, so this file, and it serves your application on this URL you see here, localhost 3000 by default. And you can then just visit this location, simply enter localhost 3000 in the browser, and now your code runs here. And why is this better? Well, this will now automatically reload the page whenever another file in this directory changes. So if I, for example, add an exclamation mark here, and I save this, and I then compile this again with tscapp.ts, and you go back to the browser, you see the latest output immediately because it automatically reloaded. And that simply saves us the extra work of reloading manually. Now, important about this npm start process, definitely keep it running as long as you are working on your project, as long as you are writing code which you want to see execute in the browser. Once you're done, you can always quit this process with Ctrl+C, but once you do so, your project is no longer getting served under localhost 3000. So keep it up and running as long as you are writing code and making changes. With that, I'll change it back, but this is totally up to you. And this is the project setup I will use throughout this course. You also find it attached, of course, in the finished form. Just one important note, if you download the attached starting project, or any other course snapshot, any other code snapshot you find anywhere in the course, then you will get a download that does not include this node modules folder. This is a huge folder which in the end stores all third-party packages and their dependencies. And since it is so huge, I typically delete it because you can easily recreate it by running npm install. So if you download one of my attachments, navigate into the extracted folder, and in that folder run npm install. And this will install all dependencies and recreate this node modules folder. And once you did this, you can run npm start or do whatever you want to do in this project. And with that, we got this project setup we'll use throughout the course. Now let's not waste any more time and let's just get started. Hi and welcome to this course. My name is Maximilian Schwarzmüller and I will be your instructor in this course. Now, this course is about TypeScript, a superset to JavaScript, so a programming language which actually builds up on JavaScript. You could say it takes JavaScript to the next level. With TypeScript, you will see in this course, you can write less error-prone, much better and cleaner code, and also use some exciting new features which don't exist like this in JavaScript. Now in this course, you will learn TypeScript from scratch. You don't need to know anything about TypeScript to get started. Basic JavaScript knowledge absolutely suffices. You will learn all the basics of TypeScript, how it works, why we use it, the different advantages it offers. We'll dive into the core types it provides, and we'll gradually build up knowledge and dive into more and more advanced TypeScript features throughout this course. Now, this course is both a course that focuses on the theory and showing a broad variety of features, as well as showing all these features in action in real projects. Therefore, in this course, we'll have a real project. We'll also have a module where we dive into TypeScript with React. We'll also have a module where we dive into TypeScript with Node and Express. So that by the end of this course, you really feel comfortable using TypeScript in your next projects, and that you know why you would use it, and most importantly, how you would apply it to any JavaScript project you're working on. No matter, by the way, if that is JavaScript in the browser with or without any framework, or if it's on the server side. So that's all in the course. I'm super excited to start this journey together with you. And with that, I'd say let's not waste any time and let's find out what exactly TypeScript is and which advantages it has to offer. So what is TypeScript? What is it all about? Why would we use it? TypeScript is a JavaScript superset. Now, what does this mean? It means that TypeScript is in the end a language, a programming language, building up on JavaScript. It's not a brand new language. Instead, it takes the JavaScript language and adds new features and advantages to it. It makes writing JavaScript code easier and more powerful, you could say. But we have one huge disadvantage. TypeScript can't be executed by JavaScript environments like the browser. Browsers can't execute TypeScript, and for example, Node.js also can't execute TypeScript. So the environments where we can execute JavaScript don't support TypeScript. What's the idea behind TypeScript then? It's a better version of JavaScript and we can't use it? Well, not quite. TypeScript is a programming language, but it's also a tool. It's a powerful compiler which you run over your code to compile your TypeScript code to JavaScript. So what you get as a result when writing code in TypeScript is JavaScript. But you didn't write that JavaScript code. You wrote TypeScript code with all the new features and all the advantages, and you get normal JavaScript code. Well, that of course brings up one important question. How can TypeScript add new features if what you get in the end is regular JavaScript? And the answer is the TypeScript compiler compiles these new features to JavaScript workarounds. So in the end, it might give you a nicer syntax, an easier way of doing something, and it will then compile that nicer, easier way to a more complex JavaScript snippet, which you would have to write otherwise. So it's not magic. Of course, it can't add what's not possible at all in the JavaScript language, but it can add new features that simply are easier to use, nicer syntax, things like this. In addition, TypeScript, of course, does one important thing, which the name already implies. It adds types. It adds a feature to the JavaScript language, at which we'll have a closer look in a second, which will actually give you as a developer an opportunity of identifying errors in your code earlier before your script runs and the error occurs at runtime in the browser. So it does not only give you some new features and nicer ways of doing something, it also gives you extra error checking where errors, which you would otherwise get as runtime errors, can be caught and fixed early during development. So why would we use TypeScript? Consider this example, a fairly simple JavaScript function which adds two numbers. Now when I call it, please notice that I'm passing in two strings instead of two numbers. And I'll show you a real example where something like this could happen realistically in just a second. So we're calling this function with two strings, and as a result, what you would actually get here is probably an unwanted behavior, because if you add two strings, JavaScript will concatenate the strings instead of doing a mathematical calculation here. So the result would not be 5, but 23, a concatenated string of the two numbers. This is an error you could have in JavaScript. It's not a technical error. You probably won't get a runtime error, but you have a logical mistake in your code. And that, of course, can lead to huge problems in the web applications you're writing with JavaScript. Now, of course, in JavaScript, we have mitigation strategies. We could add an if check in the function to check the types of the inputs at runtime. We could also validate and sanitize user input. And whilst we might want to do all of that, it would also be nice if we could catch errors like this during development already. And thankfully, this is possible with TypeScript, because developers can write invalid code here and introduce bugs like this in JavaScript. And with TypeScript, we have a tool that helps us write better code and avoid such problems. So let's have a closer look at this. Here is this same example basically in a real project. You find this simple project, the index.html file and this JavaScript file attached to this video in a zip file. You can simply open this and then open the index.html file. You can also open the code in any text editor of your choice. Here I'm using Visual Studio Code, and I will come back to my exact setup later in this module. For now, you can just open these two text files with any text editor. Now what you'll find in there is this JavaScript file which interacts with this index.html file. And in that index.html file you find two inputs and a button, and in the JavaScript file, which gets imported here, we basically reach out to these elements, then we have a function here and an event listener on the button that triggers the function and logs the result of the function here in the console. Now, if we simply open that index.html file by double-clicking on it in the Windows Explorer or the Mac Finder so that it opens up in a browser, what you'll see is this, the two inputs and the add button, and here I opened the browser developer tools as well. Now, if you enter 10 and 5 here, for example, you might expect to see 15 as a result here on the right, but instead you see 105. And this shows us a weakness of JavaScript here. This is not a technical error, it's not an error which is thrown, but it's a logical error in our application. Now, where is this error coming from though? Well, here in JavaScript, I reach out to these two inputs, and when the button is clicked, in the end, I get the values of the two input elements, and I pass them here to add. And here it's important to know that in JavaScript, when you access the value of an input element, it's always a string, always, no matter which type of input this is, if this is of type number or not, it's always a string. So I'm passing in two strings to this function in the end, and if you add two strings in JavaScript, they get concatenated instead of added mathematically, which is why we see 105, 10, and 5 concatenated. This is the issue with JavaScript here, and this is something where TypeScript can help us. Now, without TypeScript, we could of course add a if check here and check if the type of num1 is equal to number, and if the type of num2 is equal to number. And if that is the case, then I return my calculation like this, else I might throw an error, or I at least convert both to numbers by adding a plus in front of each parameter here. Now, this is some code we could write, maybe a bit more refined than this, in JavaScript, and with that we would ensure that we convert numbers or the inputs to numbers if they're not numbers yet. So with that, if I reload this and I repeat this, now we get 15 because of our changed code. So of course you can do this in JavaScript, and this is vanilla JavaScript, nothing TypeScriptish about it. But we wrote some extra code for an error, which I actually would like to prevent in the first place. I don't want that this happens. I want to make sure that we can't even pass strings here to add, because add should be a function that only operates on numbers, so that in there we don't need to check whether we get a number or not. So I want to keep this function in the state it was before. I want this function here, just like this. And that is where TypeScript can help us. So TypeScript can help us in such situations as I just showed. Now, in order to see how it helps us, let's install it. So on typescriptlang.org, you can click on download, and there you learn how to install it. And we will actually install it with this command, which uses the npm tool, and the npm tool is part of the Node.js package. So even though we're not going to write Node.js code here, we still need to install Node.js, simply because behind the scenes that will also be used by some tools we use. And when we install Node.js, we also install npm, the Node Package Manager, a tool which we then can use to install TypeScript globally on our machine. So simply visit nodejs.org and there install the latest version you find here. Simply click on this button, it will then download an installer. You can walk through that installer. It is supported for all operating systems. And once you have Node.js installed, you will be able to run this command. Simply open up your normal terminal or command prompt and then copy in that command. Important on Mac and Linux, you might need to add sudo in front of this to get the right permissions. On Windows, this will not be required. So simply make sure you then install TypeScript with this command. Enter your password in case you should be prompted for it. And with that, you got TypeScript installed globally on your machine. Now, what does this mean? TypeScript installed. Well, remember that TypeScript is a programming language, but it's only a programming language that works because we also have this compiler, this tool which compiles it to JavaScript. So in the end, what we installed here is the compiler and everything it needs to know to understand TypeScript code to convert it to JavaScript. So with this, we have the compiler installed, and we can run the tsc command now, which invokes this TypeScript compiler to compile a TypeScript file to JavaScript. So to see this, In this project we worked on, let's simply add a new file using ts.ts, for example. Any name you want, but the extension should be .ts, which stands for TypeScript. Now let's copy that JavaScript code into that TypeScript file. Here in Visual Studio Code, I immediately get some errors, which we now will fix. And this is one great advantage of TypeScript. If you're using the right IDE, and my strong recommendation really is Visual Studio Code, and I will come back to that later, then you already get great support in the IDE when working inside of TypeScript files. Here already it basically lets TypeScript analyze my code and identifies some weaknesses, which is great because that's exactly what I want. So here in this example, let me delete the JavaScript only JS file. And with that, some of the errors are gone because it identified that some constants and so on were used in multiple files, but it still gives me an error down there. And what you see, for example, is that it's not sure if there really is a value property. Now that's a mistake I didn't even consider before in JavaScript, but it's true. I'm selecting an element by ID here. Now, TypeScript can't know if this will really work. Maybe I have a typo in here. In this case, I wouldn't be able to select an element. This element simply wouldn't exist on the page. So we might have a typo, and TypeScript does not analyze your HTML code to find out if this works. So for one, this might fail. But even if it succeeds and we select an element there, it doesn't have to be an input element. It could be any other element, and most HTML elements don't have a value property you can access. And this already is great. TypeScript forces us to be more explicit, to be clearer about our intentions, and to double check our code. And for example here, and you don't need to understand all that syntax, we will learn it step by step throughout the course. But for example here, we could let TypeScript know that we are sure that we will get an element by adding an exclamation mark. This basically tells TypeScript this will never yield null. This will always find an element. And as a developer, I of course know that this will always find an element because I double check that ID and I see, yeah, I have that ID here. Now in addition, I also know it will always be an input element. So we can use as HTML input element a syntax called typecasting, which I will also explain in greater detail later, to let TypeScript know which type of element this will be. We can apply this to the second element as well. So just to be really clear here, this is TypeScript syntax. I can use this exclamation mark here and I can use this typecasting here because we are in a .ts file, we are in a TypeScript file. We will compile this to JavaScript. This would not work in vanilla JavaScript. This is not available there. With this, we are forced to be clearer about our intentions and to really think about our code and double check it, which is great. But that's not even the biggest advantage. The biggest advantage is the addition of types. That is what gives TypeScript its name, after all. And here, I'm not saying anything about the types of data this function operates on. If we hover over one of these parameters, we see this anything here. And in the end, this is TypeScript saying to us, I don't know what's in there. It could be any type of value. Now we can add a more explicit type in TypeScript files, so not in JavaScript files, but in TypeScript files, by adding a colon here and then specifying the type. For example, number. Doing this here and doing this here. With this extra syntax, which TypeScript, which this compiler understands, we're telling TypeScript that this here will be of type number and this will be of type number. And therefore now we get an error here again. And we don't just get this error in the IDE, by the way. We also get it if we try to compile this code, because that is ultimately what we need to do, right? Now to compile this, I will open a terminal, and here I'm just opening my terminal or command prompt, which is integrated into this IDE. It's the regular system command prompt, the regular system terminal I was using here as well, just already navigated into this folder. So if you are not using some built-in IDE terminal, you can use your regular one, but cd navigate into that extracted starting folder where you added your TypeScript file. And once you are in that folder, you can run tsc, that will invoke this TypeScript compiler we installed earlier, on using -ts.ts. And if you run this, you will actually get an error. You will still get a JavaScript file because by default, TypeScript will still compile it to JavaScript. You will also learn how to suppress this later in the course. But it gives you a compiler error while doing so. It tells you that argument of type string is not assignable to parameter of type number. So the problem here is that TypeScript understands that what we get on the value property of our input element will be a string. We also see this here in the IDE. And we can't pass this to add because there we don't want a string, we want a number. So we have to fix this by, for example, converting this to a number here by adding a plus. And as soon as we do this, we can compile this code again by repeating that command. And now it compiles without errors. It gives us this using TypeScript.javascript file. And now it shows some errors again because it doesn't understand that I will never use both files at the same time here. Again, this is also something which will get better later in the course. Once we configure this, we can ignore this for now. So it gives me this file. And if we open this, we see something interesting in here. We see that there, of course, our types are gone. This casting here is gone. We have vanilla JavaScript again. So if we have a look at our TypeScript file here, we see that there we have all these nice additions. But as I mentioned, these are just TypeScript features. When you compile to JavaScript, they are used to evaluate your code and to find potential errors, but then they are stripped out and we get regular JavaScript as output. So now we can go to our index.html file and import using ts.js. And that's important. Always import JavaScript files because the browser can't run TypeScript. We need to import the result of our compilation. And now with that, if we reload this, we have our working code because now we have proper JavaScript code where we fixed this issue by casting our inputs before we passed them to the function. But we were able to fix these issues because of our type annotations here. And as you saw, we had to write some other parts of the code in a cleaner way as well. And that is why TypeScript is amazing. It forces us to write better, cleaner, and less error-prone code. So you saw TypeScript in action, and it offers great advantages. It makes writing clean code really easier. TypeScript adds types, and that is super important. With types, we have to be way more explicit about how things work, and we can avoid many unexpected and unnecessary errors by using types. In addition to that, we also can use IDEs, modern IDEs, which have built-in TypeScript support, which can pick up on these types and give us better auto-completion and built-in errors which show before we even compile the code because they also understand TypeScript. But besides the types and the huge advantages we get alone by using types, we also get other features added by TypeScript. We can use certain next generation JavaScript features, which we can write and use in our TypeScript files, and then they will get compiled down to JavaScript code, to workarounds that even work in older browsers. If you know Babel, which is a tool that allows us to do that with vanilla JavaScript as well, it's a bit like that, just already built into TypeScript. We can use modern JavaScript features and still produce and ship code that works in older browsers as well. TypeScript also adds certain features which only TypeScript understands, like interfaces and generics. These are features which can't be compiled to JavaScript, but they don't have to because they are features that help us during development, that give us clearer errors and help us avoid even more errors. So it even adds more features on that front besides the types we already learned about. It also gives us certain meta programming features like decorators, on which I have a whole module in this course where you will understand what exactly decorators are, why they are so meta, and why they are amazing. TypeScript also is highly configurable. We didn't configure it thus far, but I have a whole module in the course where we talk only about the compiler and how to configure it. And you can really fine-tune it to your requirements to make it stricter or looser and to ensure that it behaves in exactly the way you want it to behave. And with modern tooling, with modern IDEs, You even get support in non-TypeScript projects. The IDE you just saw, Visual Studio Code, that even gives you better support in plain JavaScript files because it is able to use some TypeScript features under the hood without you explicitly using TypeScript. So that's a free gain you get out of the box when being aware of TypeScript and when using modern tools. So there are many reasons for using TypeScript, and that's probably why you took this course. In this course, we will now learn it step by step, and we will learn all about the amazing features it adds. This course is packed with content. We're almost done getting started, and thereafter we'll dive right into TypeScript and into all its exciting features and learn them step by step. We'll start with the TypeScript basics, of course, the core types, how it generally works, some of the new features it adds, and all you need to know to get a good understanding of TypeScript. Thereafter, we'll already dive deeper into the TypeScript compiler and the configuration of it, because it's super important for you to understand what you can configure there and what all these different settings do. So we'll have a closer look at that in this module. Thereafter, we'll explore next generation JavaScript features supported in TypeScript, how they work, and how you can use them in TypeScript. We'll continue with classes and interfaces, a super important concept, partly also in vanilla JavaScript, in the case of classes. But with interfaces, we also got a brand new TypeScript feature, and you will understand what they are, what they do, and why we might want to use them. Thereafter, it's time to dive deeper. We'll have a look at some advanced types and advanced TypeScript features in general, taking it to the next level there and building up on the basics we already learned about up to this point. Also an advanced feature, which definitely deserves its own section, is the generics feature. You will learn what that is and why it's really helpful in this module. Followed by decorators. Decorators are a pretty cool feature, also added by TypeScript, and we'll have a closer look at decorators and also build some really useful decorators in that module. And thereafter, we will have learned a lot about TypeScript. Now, the course is organized such that I show all these individual features in relatively small, simple demos. Now, to also give you a bigger picture and to see how you would apply all these features in a real project, we'll build just that. We'll have a whole module where we build an entire project entirely with TypeScript from scratch, so that you see many of these features, most of these features you learned about up to that point in action, and you see how they work together and why they simplify the process of building such a project. Once we're done building this project, we'll identify a new problem, and we'll learn how to solve it by working with namespaces and modules, which will help us make our code more manageable and readable. Building up on that, we'll also explore Webpack with TypeScript. Webpack is a build tool we use in modern front-end web development, and you can use it combined with TypeScript to get a better project setup, which simply makes certain things easier and allows you to get the best of both worlds, a great development experience and also code that works really well for your end users. Once we're done with that, we have a very solid picture of TypeScript and how to work with it in projects. Now, what you will need in a lot of real projects are third-party libraries. So we will take a closer look at that, because there are certain third-party libraries which really embrace TypeScript and have built-in TypeScript support, but there also are many libraries which don't. And we'll have a look at how we can work with both types of libraries in a great way in TypeScript projects. Well, and then there are some specific scenarios which deserve their own modules. We'll have a whole module about React with TypeScript, how you can build an entire React application with TypeScript only, and also an entire module about Node.js and Express and TypeScript, so that you also have great examples for these very popular and specific use cases of TypeScript, where you can suddenly create React or Node applications in a brand new way with a brand new language. So lots of exciting content in the course. Let's not waste any time. Let's see how you can get the most out of the course, and thereafter, let's dive in. Your success matters to me, and I want to ensure that you get the most out of this course. Now, of course, that starts with watching the videos. This is a video on demand course, so of course, watch the videos. You can go through this course step by step. It's built in such a way that all the modules and lectures build up on each other. You can also skip certain modules, of course, because all the modules also work on their own if you already know a concept, for example. Now, when watching the videos, of course, do that at your speed. You got speed controls here in the video player, and you can slow me down if I'm going too fast, or speed me up if I'm going too slow for your taste. I also recommend that you code along. It's not a must-do, but you typically learn better if you write code on your own, and you have to find and fix your own mistakes. Also pause and rewind the videos for that, because the videos are of course recorded in a way that also makes sense to people who are not coding along. So if you do, you might need to pause occasionally, try out the next steps on your own, or go back to an earlier point in a video to see how exactly I implemented something there. And in general, practicing is important. In this course, we work on real projects and we have many smaller demos. And I can only encourage you that you sometimes pause and try out the next steps on your own, or that you deviate from what I do and try out your own things. So definitely also advance on your own. Of course, only to a certain extent, because if you haven't learned about a certain feature, it might be hard to implement it on your own. But whenever possible, whenever you feel like it, definitely try out things on your own. Now, when you do that, or when you just code along as well, you will also face some errors. Things don't always go as planned, you introduced a mistake in your code, and you get an error. Now debug these errors and search on your own. Use the attached code, which you find attached to many lectures in the course, always to the last lecture of each module, so that you can compare your code to mine and find out where it deviates. But also, if you get error messages, Google them, or use the search here on Udemy to also search the Q&A section, because chances are someone else had a similar error and you can quickly fix it by looking at their solution. Now, of course, if you're really stuck or if some concept is unclear, you can also ask, but also answer here in the Q&A section. I do my best to provide quick support there, but also try to help others there on your own. Because besides fixing your own errors, if you also help others and work with other students, you get a lot out of this course as well. So that's definitely also a recommendation I have. And with all these steps or all these building blocks, you have everything you need to get the most out of this course. Now in the next lecture, I will show you the setup, the IDE I will be using throughout this course, and thereafter we can already dive into TypeScript. TypeScript is amazing, but in order to work with it efficiently, I strongly recommend that you also have a powerful code editor, a powerful IDE. And here my clear recommendation is Visual Studio Code. It's free to use and it has amazing TypeScript support built in. Now, you still need to install the TypeScript compiler, and we already did this, but this has the built-in support which shows you a lot of errors directly in the IDE before you even compiled the project. So you can simply visit code.visualstudio.com, and there you can download it for any operating system and simply walk through the installer there to get this modern IDE. Now, it is the IDE I will be using throughout this course, and you can fine-tune and configure it to your requirements and needs. Here are just some settings I'm using. Under Code Preferences, you can change the color theme, and there I am using the Dark Plus theme, so if you want the exact same look, that's the theme I'm using, but of course you can also play around with any other theme here. I also installed certain extensions, so third-party plugins, so to say, which change the appearance or behavior of the editor. You can click on View and then Extensions to be taken to the Extensions menu or the marketplace, and it's all free, no worries, nothing here costs you money. Now I got tons of extensions installed, but the extensions I would recommend that you definitely have a look at is ESLint, that you install this to get linting, to get code quality check support in your projects, and that you install the Material Icon theme if you like these file icons I have in my projects. That's a pure visual thing, of course. It doesn't change any behaviors. And I can also recommend Path IntelliSense so that later in the course, once we work with imports, you get better support there. And Prettier, which helps you format your code so that it always looks nice and is readable. Prettier works together with a certain shortcut which you should be aware of under Preferences, Keyboard Shortcuts. There, if you search for Format Document, this shortcut here is a shortcut you can always press in your code to auto-format it, to add missing semicolons, to make sure you use the right indentation everywhere, things like that. It makes your code more readable and your life as a developer easier. And that's it. You can also install TSLint, but that will be merged with ESLint in the future, so ESLint should be all you really need. With that, we can go back to View, Explorer, and you should have the same settings I have here, but also dive into the settings in general and explore them and fine-tune everything to your needs and to your likings. And with that, you have a great editor which allows you to write great code, powerful code with a lot of built-in TypeScript support, and you're well prepared to get the most out of this course.